In this video, we will explore the inverse of a piecewise function. Open a web browser and enter the following web address. Here you'll find the Desmos file that I've created for us to explore both transformations and inverses of piecewise functions. If you would like to know more about the transformations, watch the previous videos. For this video, we'll scroll down and find line 7 that says to turn on this folder. And in order to turn it on, you need to click not only the circle, but I also want you to click the drop-down arrow so that you can see the controls that we will play with here for the inverse of the function g of x. The main question again still stands. What do you notice and what do you wonder as you move the slider for c? What kind of generalizations can you make? There is a lot immediately going on in the graph. First of all, the original graph still stands. There's been introduced now the inverse graph that's in red. And I've also included here a dashed black line that is the line y equals x. And your question is, what do you notice and what do you wonder? I have listed here some of the more common things students have said they've noticed and wondered. First of all, I noticed that the x and y coordinate on the graph of g of x is switched on the graph of its inverse. So as I was moving my slider on the Desmos file, I stopped my slider here at this point, 5.4, 7.22. And notice where it stops in its corresponding point on its inverse. It has the same values, but the x and y coordinates have switched. And it's very common for us to hear that with an inverse, both x and y switch. X and y axis switch. The x and y columns in the table would switch. The x and y variables in the equations, if we had an equation form here, they would also switch. Another thing we've noticed, the graph of the inverse is a reflection of g of x across the line y equals x. And that was part of the reason why that line was drawn in here. And we see that it looks as if this line would be where you could fold the paper or treat it as a mirror, and everything on one side of the mirror image is reflected on the other side. And one more commonly noticed thing is that this particular graph of the inverse is not a function. And what we're referring to right now is what's written here in red. If we were to apply that vertical line test to just the red part of, or the red graph rather, the inverse graph, we can see that a vertical line would touch that graph in more than one place as we move it across the graph. So that's why quickly we can analyze it and say, no, the red graph, the inverse graph, is not a function. Here's some common things that students have wondered. How will the inverse behave for other graphs? For this, what we could do is return back to the Desmos file, slide up on the list of equations, and you can move the sliders from the previous videos on the transformations. As you move these sliders, you will see only two graphs in particular are moving. So these two graphs are g of x in green and the inverse of g of x in red. So in this way, we can explore other graphs and see that those relationships still hold true between a function and its inverse, that reflection and the x and y coordinates switching. One more commonly thing that is wondered is how do we force an inverse to become a function? And that's referring back to specifically the pre-calculus objective. So I'm going to draw here on this graph places where on the inverse, if we had just had only this piece, it would be a function. If I ignore everything else that's in red, then I would not violate that vertical line test, and just this piece would be a function. For that to happen, I need to find its corresponding original piece here on the original graph. So there's a couple of ways I could do this. I could come back to my Desmos file, and first need to return my sliders here. and scrolling down to the part for inverses, I could move just those points along that particular piece and try to find where is this point that I can't go beyond. In other words, I'm getting ready to restrict my domain on the original graph. And it appears that it's this point here. At this point, 8.57 is where I need to have a restricted piece on the inverse, which means 8.5 is its corresponding point on the original function. Keep that point in mind. And if we go to the other side of that particular piece, it appears that stops at about -4, 2. And again, its corresponding point on the original function is this value 2, -4. Again, keep that point in mind. So back here, I've just labeled those particular points that I gathered from the Desmos file. And the corresponding piece to the inverse part that I know would be a function, it would pass the vertical line test. Its corresponding piece here on the original function, g of x, falls here between 2, -4, and 7, 8.5. So by restricting the domain of g of x between 2 to 7, I can now guarantee that the inverse will be a function. It would be just this highlighted piece that would appear. Now, if you really want to get into more detail with the Desmos file, you can scroll down much further and see the actual piecewise function that I've written here. I do encourage you, if you are very interested in this, create your own piecewise function by playing around with some of the parameters here. And one more final note, this did not have to be the only domain restriction. Maybe you would have answered this question differently by focusing on a different piece. So for instance, we could have selected a different piece. So maybe this piece, maybe this is the one that we wanted to keep because we see that just that part would not violate the vertical line test, so it would be a function. Or maybe just this piece. We would want to keep just that. Again, that would pass the vertical line test. There's only one piece that would definitely not pass the vertical line test, and that would be this piece here, in which its corresponding part is this horizontal line from the original function. So we know for certain that no matter how we restrict the domain of the original function g of x, it cannot contain this part between x at -6 to x at +2.